Hello everyone, welcome to my channel Zoom into Physics class by Amika Mahajan. Today I will discuss electromagnetic waves for class 12. These are those waves which were first predicted theoretically by James Clerk Maxwell, and Hertz experimentally produced these waves and studied their properties. The work by Marconi led to a great revolution in the field of communication, which we are witnessing today. First of all, let's understand what are electromagnetic waves. The waves which do not require any material medium for their propagation are known as electromagnetic waves. That means they can pass through air, vacuum, or any other medium. Actually, they do not require any material medium for their propagation, and they travel in free space with speed of light, which is given by the formula C equal to 1 by square root of epsilon naught mu naught. But in material medium, the medium other than air, the velocity of electromagnetic waves is V equal to 1 by square root of mu epsilon. Basically, they travel with maximum speed in air and vacuum, but as medium changes, their speed also changes. Electromagnetic waves actually are made up of time-varying electric and magnetic fields. In electromagnetic waves, electric and magnetic field, they oscillate perpendicular to each other as well as perpendicular to direction of propagation of wave. Let's understand this point. This is the x direction in which wave is moving or propagating. Then electric field oscillations and magnetic field oscillations will not take place along x-axis. Rather, they will take place along y-axis and z-axis. If electric field is oscillating along y-axis and magnetic field is oscillating along z-axis, then what we find that both oscillations are perpendicular to each other as well as perpendicular to direction of propagation of wave. This purple part shows electric field oscillation and yellow part shows magnetic field wave. But we find that these electric and magnetic field, they acquire the shape of sine wave. What do you mean by this? If I have sine wave equation, it will be y equal to a sine omega t. Its graphical representation will be like this. Now come to this graphical part of electromagnetic wave. But I find that this wave, which is showing electric field oscillation, is assuming the shape of sine wave. Similarly, this yellow part, which is magnetic field, this wave is assuming the shape of, again, sine wave. So here, electric and magnetic fields are oscillating perpendicular to each other as well as perpendicular to direction of propagation of wave. This is the maximum displacement of electric field, which will be denoted by E naught. And this is the maximum displacement of magnetic field, which will be denoted by B naught. Now, we can represent these electromagnetic waves in equation form also. This is the general progressive wave equation, y equal to a sine kx minus omega t. Here, x is representing direction of propagation of wave, omega is angular frequency, and k is wave number, a is amplitude, y is displacement. If I have to represent electric field oscillation in wave form, then it will be represented by Ey. That means field is along y-axis, equal to maximum displacement. I am taking it to be E naught. So it will be E naught sine kx minus omega t. Similarly, oscillations of magnetic field will be represented in wave form in equation form by Bz equal to B naught sine kx minus omega t. These two equations represent mathematical representation of electromagnetic waves. Now, electromagnetic waves are transverse in nature. Let's understand what is transverse wave. The wave in which particles vibrate perpendicular to direction of propagation of waves are known as transverse waves. Now, in this case, what is happening? This purple part, which is showing electric field oscillation, and yellow part, which is showing magnetic field oscillation. These oscillations are in a direction perpendicular to this direction of propagation of the wave. So, electromagnetic waves are transverse in nature. Electromagnetic waves have maximum displacement in the form of electric field as E naught and in the form of magnetic field as B naught. Then ratio of amplitude of electric field and amplitude of magnetic field gives value of speed of light. So in this video, what we have learned that electromagnetic waves do not require any material medium for their propagation. They travel in free space with speed of light, which is given by the formula C equal to 1 by square root of epsilon naught mu naught. In material medium, velocity changes to V equal to 1 by square root of mu epsilon. So they travel with maximum speed in air or vacuum, and electromagnetic waves are transverse in nature because electric and magnetic field oscillations are taking place perpendicular to direction of propagation of wave. These oscillations are also perpendicular to each other. At any time, ratio of amplitude of electric field and magnetic field gives value of speed of light. If you have liked this video, then share it and subscribe to my channel. Thank you.